on your end if you'd like. Okay, well, first off, I'd like to take the time to thank you for attending today's presentation. My name is Lance Zurich, and I'm the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of Fischertechnik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level who's involved in CTE training, college professor or industrial trainer teaching programming skills required in manufacturing, a company looking for ways to demonstrate their software-based solutions, or maybe you're someone looking for ways to make IoT-related concepts easier to understand to your employees or your customers. But in any case, I believe this presentation will offer some important options for you to consider. Now, let's start off by considering the skills gap. Now, if you've attended any of our other Fischertechnik education-focused webinars, you've probably heard me discuss the importance of STEM education. Now, STEM, of course, is the acronym for science, technology, engineering, and mathematics, and it should go without saying that STEM education has been perhaps the most discussed topic in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help us best prepare them to take their place in the modern workforce. Now, not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing becomes more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. Now, as it ties in directly with the solutions we'll be looking at in this presentation, let's consider that last skill area I just touched upon, that of a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain very briefly what a PLC is. The term PLC is an acronym, the letters of which stand for Programmable Logic Controller. Now, essentially, a programmable logic controller, or again, PLC, is a very specialized computer used to control the types of machines and automated processes that are typically found in an industrial setting, such as in an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. To get a clear idea of how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar, I took a look at the list of current job openings for PLC programmers on Nuvu, and this was for the date of February 27th of 2020, last year. Now, the listings at that time showed 15 positions being advertised with salaries of over $75,000, two of which listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. And at the same time as this is occurring, the workforce of tomorrow, and they get their training, more and more manufacturing companies facing an urgent need right now are enrolling their incumbent workers into private training schools offering such programs. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. Of course, to become truly proficient in all 5 of the most widely used PLC programming languages, as you see listed here on the screen, as well as learning how to efficiently troubleshoot and address errors and equipment breakdowns, more training, of course, would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are many other options available, such as high school CTE career and technical education programs, adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, whether in the university or the vocational school setting, is how do you teach PLC programming in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it realistic and hands-on? But there are also other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. For example, it could be a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. In each of these cases, and many more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of Fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method of teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in appearance and function, various automated robotic machines and systems commonly used in manufacturing. But before we look at each of these models, let me provide you with just a little bit of background on what exactly Fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, based around their unique building system. Now, what makes this system unique is that unlike other popular construction sets where the components are designed to simply stack, with the Fischertechnik system, it was created with more of an engineering mindset. The core building block in the system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place, and the hundreds of different parts available also help to address very specific design needs. The Fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. And besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, and they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fischertechnik sets, whether it be those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products offered by Fischertechnik for the education sector are subject-specific sets focusing on different STEM-related areas such as mechanics, pneumatics, robotics, or renewable energy. In many of these sets, students are asked to build a progression of models using the unique Fischertechnik system, and then perform various experiments which allow them to explore and understand aspects of that subject. Now, there are also sets designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria put forth in a series of real-world scenarios based upon their own trial and error experimentation and research. The line of Fischertechnik simulation solutions, which are the focus of today's presentation, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic models and systems. Models in the Fischertechnik simulation line include conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, Fischertechnik also offers an integrated factory simulation model. And this model consists of 4 individual workstations, a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all working together as one self-contained material cycle. Before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using Fischertechnik solutions. Now, I will apologize in advance as the first few points are things I've touched upon before, but I think in each case it is worth repeating. First, Fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, both in appearance and function, commonly automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each Fischertechnik simulation model is a hand-assembled, high Each of these models is available in a 24-volt version, which is designed for use with industry standard PLCs. Now, whether you use Allen Bradley controllers, Siemens controllers, or controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or many others, you can control these 24-volt versions with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming languages. Whether you like ladder diagrams, sequential function charts, function block diagrams, structured text, instruction list, what have you, you can use that language. Now, please note that with these 24-volt versions of the models, no PLC is included, and all programming and programming guidance, as well as any power sources or other hardware, are the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or those teaching or exploring industrial processes involving PLC programming. In addition, for non-industrial users and educators not versed in or familiar with PLC programming, there are several models which are also available in 9-volt versions. These 9-volt versions ship pre-wired to Fischertechnik's own proprietary robotic controllers, which are the Robotics TXT controller. And each controller in this case is pre-programmed using Fischertechnik's own RoboPro graphic programming software. The only additional component required with the 9-volt versions will be the addition of one or more 120-volt power adapters as specified with each model. Otherwise, in most cases, these models should be ready to use right out of the box. If you are involved in demonstrating or exploring IoT, which of course is also known as the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions for IoT purposes, Fischertechnik also offers a special IoT-focused version of the factory simulation designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And we will, of course, discuss this in more detail later in this presentation. Finally, Fischertechnik simulation models are cost-effective. If you've had the opportunity to look into any of the other hardware-based industrial simulation options in the marketplace, you'll probably notice that the entry point for many of these products can easily be $20,000 to $30,000 or even more. Fischertechnik simulation solutions, on the other hand, are available at just a fraction of that price, as well as being compact, realistic, and high-quality learning and demonstration tools. So on that note, we're going to start our look at each of the models which are currently available. First up is the vacuum gripper robot. And we're just going to let this, there we go. Now, as you can see, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component you'll see in the video, and a solenoid valve. The model's dimensions are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt versions of this model, as well as all of the first 5 24-volt models we'll look at today, each have a relay board for motor polarity reversal, and also both have a multi-pin connector with 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as all 24-volt versions, will require you to provide the PLC and the programming. And for a limited time, there's also a 9-volt version of this model available, which is the version you see in this video, which will come once again wired to the Fischertechnik Robotics TXT controller and will ship fully programmed using RoboPro graphic programming software. Now, if you wish to create your own programming, individual licenses of RoboPro are also available on our website. Otherwise, for this 9-volt version, only the addition of a single 120-volt power adapter will be required. Now, I will mention that for this and for all of the models we're going to look at today, the specs are also detailed in the product listings found on the Studica website, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. Next up, we will look at the automated high bay warehouse. The model we'll see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays in 9 individual storage spots. Components of this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each piece, each step which will of course require its own very specific coding. The dimensions for this model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide your own PLC and programming. And a limited edition 9-volt version is also available at this time, which again is pre-wired to a pre-programmed TXT controller, and again, one 120-volt power adapter is required. The next model in the line is the multi-processing station with oven simulation. The model we'll see here features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 11 pounds. Again, the standard version of the model is a 24-volt version for use with the PLC of your choice, with once again a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeter, as well as additional PCB terminals with pushing connections for all inputs and outputs. The limited edition 9-volt version in this case is connected to two robotics TXT controllers, so here 2 120-volt power adapters will be required for all operation. The next model in our progression is the sorting line with color detection. This simulation features a system for detecting workpieces of different colors and sorts them via a conveyor belt into 3 different storage bins. Components on this model include 2 MIDI motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as with the models we've looked at before, again, the standard 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you will need to provide your own PLC and the programming. The limited edition 9-volt version, again, comes pre-wired to a pre-programmed TXT controller, and one 120-volt power adapter is required. And that's all of them. The next model is the factory simulation, which combines the 4 models we've just reviewed: the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection into one self-contained material cycle. Video is just lagging a little bit here. We'll let it catch up just a second. Okay. The cycle you're going to see here works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then moved to the multi-processing station with the oven. After the work piece has been processed by this machine, it's then sorted by color in the sorting line with color detection, before again being moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I won't belabor it by restating them here, but what I do want to discuss are the dimensions of this model as a whole. As it again combines 4 individual models into one work cycle, it has a much larger footprint of approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending on whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model will only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models tend to be in high demand, please anticipate a possible turnaround time of up to 3 weeks prior to any orders for this model leaving our warehouse. And we seem to have a little bit of a lag here. Hang on a second. Now, a few other things to note while the video is moving a little slow here. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in the case of the 9-volt version, It's wired to 5 robotics TXT controllers, and because of this, it will require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs, all programming, and any other hardware required. Again, each station on the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed, who might need to transport the model or who wish to protect it when not in use. The travel case consists of an aluminum casemaker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, with a weight itself of approximately 53 pounds. Please note that even when using this travel case, these models will still need to be shipped flat. The next model is a basic conveyor belt, and this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of the transport as you might desire. Components on this model include an XS motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of this model are approximately 14 by 10 by 4 inches, and it has a weight of under 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, but in this case, that's 26 pins with a 2.54 millimeter grid, as seen here. And for a limited time, we also offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. One 120-volt power adapter is required for operation of this 9-volt version. The next model is a variation on the conveyor belt, which includes a punching machine. This features essentially the same conveyor as we just looked at, except that this time with a machining station built in. Components on this model include 2 XS motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a total weight of about 3.5 pounds. Again, it's available in the standard 24-volt variation with a 26-pin connector, 2.54 grid, as shown here. And for a limited time, we will be offering a 9-volt version wired to the robotics TXT controller, which again requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station and 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 XS motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of this model are approximately 19 by 18 by 11 inches, and it has a weight of about 8 pounds. Available once again in both the standard 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLC, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next is a variation on the idea of a pick-and-place robot, or the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees, Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of this model are approximately 19 by 16 by 9 inches, and it has a weight of about 6 pounds. And again, this comes in either a 24-volt version with a 26-pin connector and 2.54 millimeter grid, as seen here, designed for use with the PLC and programming of your choice, or in a 9-volt version, which in this case is not a limited availability model, but is a standard model as well. And once again, this comes wired to a pre-programmed robotics TXT controller, and it requires one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models focus on the area of IoT, as I hinted at earlier, and are designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both a 24-volt version for use with PLC and also in 9-volt variations for classroom and demonstration purposes. They've been designed to help address how the recent changes in industrial production, driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a large scale. Now, as the following video showcasing the 24-volt version provides a nicely narrated overview of how this factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator.
Fischertechnik learning platform 4.0 illustrates processes for a digitized smart factory of delivering raw materials to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale.
Oh, excuse me. Hang on a second, bear with us here. We'll get this straightened out. Again, just having a slight technical difficulty here, so please bear with us while we get this unfrozen, because this is really the star of the show.
Illustrates processes for a digitized smart factory of delivering raw materials to the finished product. Industry 4.0 applications. Can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC.
Okay, don't know what happened there. Let's see here. Try that again. Again, I apologize here. We seem to be having a little bit of a freeze here.
Module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as color. The material is sorted using pneumatic cylinders.
Apologize for the connection problems we're having here. I'm not sure why we're doing that.
Before they are used on a large scale.
Unfortunately, we're going to abandon the video now because that seems to be causing us some issues. But let's see here. Now, the following topics can be addressed with the Fischertechnik Training Factory Industry 4.0, just to pick up on some of the things the video stated, but just restate them again. Training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, and digital traceability with NFC/RFID technology. It allows for customized production in lot size 1, integrated cloud control, cloud connection and control via smart devices, using and operating dashboards, and web-based remote maintenance. Also the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, more or less, the model incorporates many features not found in the models that we previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the position of the workpieces in the work cycle to be mapped. And the use of MQTT, message queuing telemetry transport, allows the network TXT controllers to communicate with one another. Now, as there are 2 variations of the model, let's go over what makes them different aside from the voltage requirements. Now we'll begin by focusing on the 24-volt version and what makes it unique. First, it is a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one Fischertechnik Robotics TXT controller. The TXT controller serves as the MQTT broker and interface to the Fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the Fischertechnik cloud, as we just saw in the 9-volt version, but also be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, which is pulse width modulation. They also have push-pull output stages for phototransistors and for buttons. Finally, one of the most important new features. Unlike any of the previous 24-volt models that we've discussed or looked at today, the new 24-volt Training Factory Industry 4.0 also includes access to a sample program that's been created for use with this model. This program, which is in structured text format, was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. The source codes needed for making these adjustments are available for download also from GitHub. And now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model have a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters for these particular models, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which accompanies the model and can also be downloaded directly from the Fischertechnik website or from the Studica website. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all of the other 9-volt versions we've looked at previously today, these are programmed not using RoboPro, but instead using C++. Again, all programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF made specifically for this model, you should be able to get started quickly. This 9-volt version will require the addition of 3 120-volt power adapters, the ability to access the internet, of course, as well as a tablet or a device for accessing the cloud-based dashboard. The dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, again, depending on the version that you purchase. Now, as with the 2 factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0, again, available in both 9-volt and 24-volt variations. Of course, you might well be wondering how much these models cost. So with that in mind, let's take a quick review of each option I've discussed, along with the pricing for each. We'll begin with the vacuum gripper robot. The 24-volt version, again requiring PLC, is $899 each. The 9-volt version, while it's available pre-wired to the robotics TXT controller, is $1199 each. The automated high bay warehouse in the 24-volt version is $1,035 each. The 9-volt version, again pre-wired to the robotics TXT controller, is $1,319 each. Multi-processing station with the oven. In the 24-volt version, these are $989 each, and in the 9-volt version, these are $1,479 each. Sorting line with color detection. The 24-volt version is available at $819 each, and the 9-volt version is available for $1,129. The factory simulation in the 24-volt version, this is the non-IoT version, of course. The 24-volt version is $3,729. Of course, PLC and programming is required. The 9-volt version, pre-wired to the robotics TXT controllers, $5,239 per unit. The conveyor belt in the 24-volt version is $220 each. In the 9-volt version, pre-wired to the TXT controller, is $519 per unit. The punching machine with the conveyor belt. The 24-volt version is $289 per unit. The 9-volt version, again, while it's available, $599 per unit. And the 3D robot. The 24-volt version is $829 per unit, and the 9-volt version is $1,099 per. The index line with 2 machining stations in the 24-volt version is $879 each, and the 9-volt version is $1,399 each. And the star of our show today, the Training Factory Industry 4.0 for exploring, demonstrating, and understanding IoT and cloud-based control. In the 24-volt version, again coming with the sample program, $7,635 or $7,365 per unit, excuse me. And the 9-volt version, again, pre-wired to the robotics TXT controllers, that's $6,495 per unit. Other items that are available, as I've touched upon it a couple times, the 120-volt power adapters, which are used for powering the 9-volt models, those are available for $12.99 each. And the travel and storage case, which is used for both of the factory simulation models, the 9-volt or the 24-volt version, as well as both variations of the Training Factory Industry 4.0, again, the 9-volt or the 24-volt version models, those are $1,000 each. So at this point, since you've been able to sit with us through a couple glitches, auditory and otherwise, and you've shown patience, I'd like to open up the floor for any questions you might have. And of course, I would ask that you please use the Zoom chat window or the question window, either of which, of course, are available on the Zoom toolbar. I will give you one, give you two. I will say if you don't have a question at the moment, but if you might after, then this next slide, which I will bring up. Oh. Taking the next step, this has my email address on it and our phone number as well. So if you'd like to request a full color brochure with the current pricing, if you would like to ask any questions about any of these models directly, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative, if you're calling with a school or a training program such as that, I would put you in touch with one of the educational representatives, or you can speak to me. Either way, you can call us directly at Studica, 888-561-7521. If you have general inquiries about the Fischertechnik training models, you can email us at info@studica.com, info@studica, studica.com. Or if you have any questions for me directly, lance.zurek@studica.com, lance.zurek@studica.com. On that note, thank you very much for attending today. Have a great afternoon.